So, hi everyone, I'm Dr. M. Karpagam, Assistant Professor, Civil Department, SRM IST, KTR campus. So, now in this video, we'll just see what is self-referential structures. So, in the previous video, I have been covered what is structure and what is array of structures. So, in this, we'll see what is the importance of self-referential structures. So, actually, self-referential structure is so where when you are speaking about array, so the array is a static memory where once you just fix the size of the array, we could not able to change the size of the array during runtime. Okay, so now regarding structures also the same thing, but when you're speaking about self-referential structures, so we'll be able to change or handle the size dynamically in the arrays. So these self-referential structures, they are very much used in the complex algorithms, and it is mainly used in creating a list, a linked list. So in linked list, we'll be having various types. We'll be having also we have been used for creating a stack as well. But when you're speaking about a linked list, you can see this is a structure of linked. This is how your linked list will be looking like. So here, this everything is called a separate node. Okay, so each node they'll be having two separate partitions. One is for data, the other is for the address or a pointer or a link. I can say it's a link. So when there is no link, when there is no this arrow is placed, so this is like a separate node. Each thing is a separate node. Once you link with the next pointer, okay, the pointer is used to link each and every node actually. So this next is storing the address of the node which is it is pointing to. Okay, so the next will be having the address of this node. The next will be the value. Actually, the value of this next will be the address of this node, because you can see this. This is a node. Each node, this node is linking to this node, which means that they both are connected. So in this way, we'll be having the next. The value of next will be the address of this node, whatever it is connected to. Okay, always the starting the node data value will be the head pointer. Always it is pointing to the data value of the first node, first data actually. And the last thing, because as this is a node, we do not have any other upcoming node to link to this particular node. So this, the pointer value of this next is null. Okay, when we have to insert a node, we can insert in the last, then your next value will be changed from null to the address of that new node. This is how your linked list works. This is singly linked list. So where we have only single link. So for this we are going to write a program. So in this record we will be having a self-referential structures. So same like a structure we used to create a struct keyword, then structure tag, the variables, that is your members, all these things. The only thing which you want to include is the link. Okay, so here is a link actually. This is your structure link. So we have seen now in this, you can see this is data value and this is your link. So here we'll be speaking about this as a main structure link. That's what here the variable 3 will be acting like a next. Okay. So we'll be seeing a program, how to execute it. So now I have a structure of C program. So where which I'll start with a self-referential structure. So starting will define the structure. So we'll be having, we'll just have the list as a name of a structure here, structure tag, and then I'll open the structure. I'll have, actually I'm going to have a node value, data value and the link, okay. I'll have only one value which is to be referred as A, the only one member which is of integer type. Then I'll just create a structure link, so which can be created by using struct keyword and the structure tag and the link by using a dereferencing operator. So a dereferencing operator I'll just use that I'll be mentioning as B, okay, for easy understanding. So this is your structure link, okay, and I'll be end up with a semicolon. So now everything is done. Actually creating a self-referential structure is done actually. Now I'll be creating a structure variable which is a local variable here. So here I'm just going to create, as you can see this PPT. So here in this thing, let me just go to the, here. You can see this, I can just have this x, y and z. Okay, we can have that. We'll be creating a three structure variables. So let me create a three structure variable. I'll just create structure, then my structure tag is list, and then I'll give x. So x, I'll just initialize the values here. So for this particular thing, when we have a data value and the pointer, we have to mention it as a set, like a set. Okay, so I'll be giving this as an integer. Actually, starting value will be the integer. You can see this thing. This is data. This is your integer value, and this will be your pointer. Okay, so I'll just give it as a starting. I'll just give one value. I'll just give 5, comma, and it will be having a null actually. Okay, this will be null. I'll just have like this. So starting, as of this program is concerned, starting I'll just think that nowhere it is connected. Okay, this is for x. Same thing I'll give for y. I'll just give for y, and then I'll just give for z as well. Okay, this can be like multiple structure variable can be created by using comma. Okay, I'll just give for y. So y, I'll just give this value to be 15, and I'll just give this as z. So this can be considered as 25. I'll just give some values. So starting, this null represents that there is no link between these nodes. Okay, so now we have to change this null. Okay, this has to be linked with y. Okay, and y has to be linked with z, which means I'm going to store the address of y to x. Okay, and then I have to store the address of z to y. So when you're speaking about storing the addresses, we need a pointer. So without pointer, we could not able to work. So in this regard, as x, y, z are all a structure variable, we know that when we are just working with any kind of type of data, we need that kind of a type of pointers to store the address. So same way, I just create, as we have three variables, I'll just have three pointers. I'll have star p1, star p2 and star p3. So I have three pointers now. So declaration of structure pointers is done. Now I'll just initialize the pointer value. So p1, which takes up the address, which stores the address of x. Okay, and then the same way you can just give for p2, p3, all these things. So p2, and this is for p3. I'll just change the values. Okay, so you can see here. So here p1, this will be the p2. So p2 is a pointer which stores the value of address of y, and p3 which stores the address of z. Okay, so now all the addresses has been loaded, stored now. Okay, now the pointer declaration is done and initializing the pointer is also done. Now what is our value? Now we are going to link. Okay, so this is actually, we know that this is a and this is b, because we know that a is a data value, this is data value, and b is the link value, b is the null actually. Okay, now we have to have that as x, we have to load the value for b. Okay, now we have to like assign the value for b. So assigning, by using assigning operator, okay, we just give x dot b by using assignment operator. Okay, we know equal to is the assignment operator. So here x dot b means what I have to store? I have to store the address of y, because this has to be linked with x, right? So where is address of y is located? P2. I'll just have P2 here. That's it. P2 is given to x dot b. Now this will be loaded with this address. Again what we have to do? Again this is like nodal. Now y dot b. You can just give y dot b. Sorry, I'll just give here y dot b. Okay, this should be given to where we have to give this z to be linked with y. So I'll just give here, where is z address? P3. Okay, that's it. And this actually like z dot b cannot be, we don't have any other node here, so it should be null. As of the like thing we discussed before, we have seen here, right? This should be null actually. The last node link should be null because we don't have any other further nodes are available. So in that case, we have just for this x dot b, this is your b value for x. This is has been loaded with the, as it is linked with y, we have given the address of y, which is p2, which has been taken the address of y. And then this is null. Again, this has been replaced with the z address because these both are linked together. So this will be replaced with the address of z. Address of z is given to p3. So that is also given. So everything is now loaded. Okay, now we'll just try to print and see. We'll just print the address of, now we need to have the address of x. Okay, x is, we'll just give percentage d, and again a value, I need to get this actually to check whether the a value is this or not. Okay, I just give value of a is, value of a is what, again that is to be replaced with some value percentage d, and then we'll see this x address of x. What is this address of x? Okay, or else I just check with address of y, and we'll just check with address of p2. Okay, address of p2, we'll see actually like this is where we have address of y and address of p2 has to be same. Okay, so we'll see that actually, and that has to be given by value, that should be like comma, address of y is like where it has been loaded, address of y, this should be p2. Okay, comma, so value of a should be, again this should be where, this one, yes, so x dot a, because structure variable only we can use, and then comma, and this will be like x dot b. Okay, so this is your address of, this is for y. Okay, and this is for x dot a is a value, and x dot b is your a linking address. I can say that link address for x, like that we'll see. Okay, so this is where we have given. Now same thing can be like printed for y. Okay, so same thing we'll see for y, address of, okay, address of this will be address of x. Okay, address of x, this will be your p1, and then this will be address of y, your p2, and here I'll be asking for y dot a, this is value of y, and this will be the link address for y. I'll be having y dot a and y dot b. Okay, we'll see that whether it is like working fine. We'll see any errors it is showing it. Just try to execute it. If there is any error, we'll just try to rectify it. We'll check for the error or output. Okay, let's wait for its loading. So I just repeat it actually. So yeah, we got the output actually. I just print that in a new line so that you have some understanding about what it is displaying. Okay, let me like give the new line here. So give me some seconds to just add this new line. So always like give some new line so that you have some pleasant display of your output, so that the end user understands what's happening. So let's see, like you can see here now. So this is the value of the address. Okay, the value of the address. So here this is the value of the address of x actually. So here you can see this this ppt here. So this is your address actually. Okay, this address we have been looking into. Okay, and so here you can see here this is the value of address, and value of a I have got 5. Okay, and then link address for x is, this is your y address actually. If you see the address of y and this link address for x, both are same. So the x has been connected to y now. Okay, the value of y is 15. Again, the link address for y is different actually. You can say I haven't displayed for the z actually. I'll just display that for z. Okay, so here I'll just display that for z. Sorry, z, and then this will be for value of z is, and the value of z actually z it is not actually we have given. We'll just take like that only. We'll just give the address of z is p3, and this is for Z for A and Z for B. Okay, now just let's run the program. You can see, let's wait for the output. So now we have did our small modifications where we have just added the Z value with the output. Before we got the X value address, and also we have just see, you can see this. So always this will be like different for each and every PCs actually. Okay, so the address of X is like this one. The value of A is 5, we know that. The address of X which is linked to this is this address, and the Y address are same. Okay, this proves that the node X is linked with Y. Okay, the value of Y is 15. Now the address of Y which has been linked, because the address of Y is linked with Z actually. So you can see this and this are same. Now this is the thing which is proving that your Y is linked with Z. And you can see here the linking address which is Z dot B is 0, because nowhere the node of Z is connected to the other node, because it's the last node. When your next pointer which is a link pointer is null, it proves that that node is the last node. You please always remember that when your link address of one node is null, then that is the last node. You can see here, when your next pointer value is null, then that proves that this is the last node. That's why the last node Z does not have any link address. Okay, so this is your self-referential. Okay, so self-referential, we have just created a link of the structure, and we have a pointers, and we will be storing all the address of the like unlinked variables, structure variables. Then finally we just load all the addresses. So based upon the structure you want, you can just assign the value of the address to the link. Okay, if I want that to be in a reverse way, if I want this to be in the reverse way, then we have to accordingly load like that. Okay, here like my X should be the last node. Now we have to like locate the address of each and every node in a different way, so that my X will be the last node. So based upon your requirement, the linking of the address here, okay, especially this one has to be changed. Okay, for example, if I want X to be the last node now, then the Y should be linked with X, Z should be, Z dot B should be linked with Y, which means that Z dot B, then I have to give Z dot B is equal to P2. Okay, because my Z has to be linked with where? Z has been linked with Y. Now this arrow will be like coming like this only. Okay, now again if this Y link has to be linked with X, then Y dot B should be P1. Y dot B should be P1. Now I totally changed. This structure is like how it is looking now. I'll just show you in the paint. Okay, so this structure exactly is like I have X. Okay, I have X here, and I have Y here, and I have Z here. Okay, and each node they have a link node and a data value. So each thing like it's like looking like this. If you see here, I have given Z dot B P2. So P2 is address of Y. So I'm just linking this to Z to P2. So now the arrow mark is like this. Okay, next is like Y dot B is given to P1. So Y dot B, this one, is given to P1. So now it is like focusing or traveling towards the X. Now your X, I didn't mention X dot link. Okay, nowhere it is given that, because it is the last node. Now this will be like pointing to null. Now the structure has been changed. You can see the differences, how it is working. Before it was like this actually. Before like it was like this. Now I have changed the program to like this. Like this I have changed the reverse way. So this is how you just change a link. Okay, you have to like simply just get to know like my node where to point it, to which address it should be pointed. You have to see that where is that address has been loaded, to which pointer, that pointer value you have to give it. That's it. This is called self-referential structures. Hope you understand. Thank you.